answer you wrote out. So the answer you are trying, like you just wrote now, it is more structured to be honest, but it has some components where personally I zoned out when you were talking about the energy conversions and like blah 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 blah. But energy conversion points should be there because the enthalpy is like basically enthalpy is converted into the kinetic energy, which is then transferred to the compressor, and the compressor is converting that kinetic energy to the pressure energy. I think this
Hello,
is one of the important
hello,
points.
Kamlesh. How
Yeah,
the enthalpy is converted, na? Enthalpy is the total heat contained in the system. So
yeah.
it should be pressure energy, na? So
No,
how
no,
the
no,
enthalpy is
Warm
converted?
bucket,
no, 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 no. It's
dipping in
enthalpy.
water, clothes.
Enthalpy. It's always enthalpy. Whenever you're talking about the turbines,
Wait, I will
it's
try
always
some water
enthalpy.
bucket.
Yeah. Hello.
Yeah. Hello, Jack. You were saying something.
Okay. Okay. Go ahead.
I didn't ever satisfied. Why the enthalpy, na? Cause the
So
exhaust gas
see,
has the pressure, na?
No. No. Pressure
Why
energy.
enthalpy? Enthalpy is also there.
No. Pressure energy of the gas converts into kinetic energy, bro.
Yes, I know.
Uh,
But why all the saying are the enthalpy is converted into the kinetic energy? Enthalpy is
mm,
converted to kinetic energy.
no.
Enthalpy has the total heat contained in the system, na?
Yeah.
Just it.
That's it. I also agree with you. Yeah, guys, tell me now. Uh, guys, I
It
want
is.
I want to ask
from the
all of you, Kamlesh bro and Kiran and Hifazat, that sometime I also want to reply like you people, okay? But the answer I got before starting the this session, na, it is so much theoretical that I find myself so absurd that if I tell this answer, it will be so monotonous and just I have answered this now. I got only this type of answer. So what I should
Hello.
do to like make it in layman and make it in own way that one can understand easily, not to mention this and okay.
Try to
देखो
watch its video.
जैसे 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 तूने आंसर ये बताए ना
Hmm.
वो बहुत अच्छे पर थियोरटिकल में जब मैं पेपर चेक करने बैठूंगा तेरा
yeah.
मुझे लगेगा
I'll
वाह
give
वाह
you full
कितना
marks.
अच्छा बंदा है वाह रे वाह क्या एक्सप्लेन किया है डिफ्यूजर
Thank you.
रिंग इम्पल्स टरबाइन इधर से उधर एनर्जी कंजर्वेशन
Hmm.
बट जब अगर मैं इसे सुनने बैठूंगा ना मुझे लगेगा क्या बकवास कर रहा है
ये तो
कुछ ही
चतुर आ
बोल
गया.
रहा है इधर से उधर इधर से उधर इधर से उधर
हाँ.
जिससे रट्टा मार क्या है
हम्म.
सो फॉर लाइक एक्सप्लेनिंग सपोज ऐसा एक्सप्लेन कर
हम्म.
अगर तू मुझे बता रहा है और मैं तुझे बता रहा हूँ तुझको समझ आ रहा है क्या मैं क्या बता रहा हूँ
हम्म.
बस ठीक है पर मुझे नहीं समझ आ रहा है ना तू क्या बता रहा है
हम्म.
तो पहले क्या करना पड़ेगा तुझे तुझे खुद को ही समझना पड़ना है तुझे समझना पड़ेगा तुझे क्या समझना है
हम्म. या.
ठीक है तुझे पहले वीडियो देखने पड़ेंगे
हम्म.
खुद की लाइक एक्सप्लेनेशन तैयार करना पड़ेगा हिंदी में
हम्म.
उसको ट्रांसलेट करना होगा इंग्लिश में
I
और वो
have to
रिपीट करना होगा
I have to make it in my own way. So I am
यस यस यस
thinking of only in session only put 5 questions per day. That I prepare that 5 question in best way. When we will be discussing, then I also contribute toward giving explanation. Since I am fresher now, so I need to know more like something I lack while
हेलो
explaining. Is it?
Yeah, in short, I just want to say,
Uh,
read your answer from the perspective of the listener.
okay.
यस
Correct. Correct.
हेलो
Hmm.
हेलो just I tried to find the one question uh, from since 15 days, but I didn't even get the answer.
Okay.
So we know that what is the function of the dryer inside the vapor compression cycle?
Yeah,
Anyone?
we
Anyone?
know that we
Absorbs the water.
absorb the water,
Yes,
moist,
yes, yes.
absorb
Stop,
the
stop, stop.
absorb
Okay,
the
okay.
moisture.
Bus.
Sorry, moisture.
Yes, yes, yes.
Moisture,
Moisture
sir.
water. Yes, yes, moisture. So how the moisture is introduced to the vapor compression cycle? Because vapor compression cycle is the closed cycle. That means it only flows the refrigerant. That means refrigerant is converted into vapor and liquid, vapor and liquid. So how water is introduced to that system? Anyone knows? Anyone knows?
First, tell me the location. The first, tell me the
Bro, bro, bro.
location of
Uh,
dryer. I will tell. location of
We mostly add it in the thermostatic expansion valve because I remember when I used to work with my uncle who was Asian fridge repairer. We used to put the silica gel, that is the what is it, dehydrant,
Yeah,
in the thermostatic expansion valve only, near the thermostatic expansion valve. While after repairing, before starting the compressor, we put that because the air moisture which must have entered inside the compressor and the tubes will get absorbed by the silica.
Hifajat, put your mic away from your mouth, yaar. We are not able to
Yes, yes.
listen.
अरे यार आदत हो गई, क्या बोलूं भाई, थोड़ा
Yes.
समझो थोड़ा.
Listen, maybe that's why you last time you faced that issue. This time you give interview na put your mic away from because your voice last time was also not clear while turbocharger.
yeah.
मेरा
It
क्वेश्चन
catches
अच्छा,
up lot of breath.
समझ में नहीं आता क्या, मैं तो बोलना चाहता
नहीं
ना
नहीं
यार.
नहीं,
No, I tried
अरे
to
मेरा
explain.
क्वेश्चन सिर्फ ये है कि वाटर कैसे आ गया ये वेपर कॉम्प्रेशन साइकिल में?
अरे
वेपर
एयर
कॉम्प्रेशन साइकिल
एयर
तो पूरे
मॉइस्चर रहता
क्लोज
ना,
है।
एयर एयर एयर, उसको उसको अपन अब्सॉर्ब कर लेते हो, जो सिलिका जल डालते हैं ना,
तो
सिलिका
नहीं है ना, एयर तो नहीं है ना वेपर कॉम्प्रेशन
है.
साइकिल में। वेपर कॉम्प्रेशन साइकिल
अरे
तो पूरे
भाई
होल क्लोज्ड है ना।
कब डालते हैं हम लोग सिलिका जेल, वो कब डालते हैं ये बताओ, जब वो ट्यूब
सिलिका जेल।
Ifazat, he is not
हाँ.
asking why we are trying it. He is asking where that moisture is entering the system.
कम
Yeah.
एंटरिंग द सिस्टम।
That's what I'm telling, bro. While we repair that tube now, at that time we open the we segregate the tube and try to check for leakage. And because of the leakage, the moisture can enter inside it. Water, sorry, air content can enter inside it. So it will. So so that's why we add. समझ रहे हो?
नहीं नहीं नहीं,
You
नहीं समझ.
सच में नहीं।
and
I mean, yeah,
अच्छा ये बताओ किरण,
you are
ये
trying
बता.
to say that it's because of the maintenance operation where we are trying to
Yeah, when we do maintenance, at that time only we add. जब भी वो ट्यूब को देखना खोलते हैं ना अपन,
I
चेक
think
करने के लिए, एट दैट,
uh,
ऐसा तो ऐसे डालने की जरूरत नहीं रहती है. मगर जब हम लोग खोलेंगे उसको रिपेयर करके वापस सील करके अब वापस से क्लोज सिस्टम बनाएंगे ना, क्लोज सिस्टम सील करने से पहले उसमें हम लोग डाल देते हैं क्योंकि एयर जा सकता है ना ट्यूब में.
uh,
समझ रहा है? तो
yeah.
वो जो एयर रहेगा ना, तो उसको रिमूव करने के लिए हम लोग वो सिलिका जेल डाल देते हैं ताकि वो एयर एब्जॉर्ब हो जाएगा उससे.
Uh,
अभी समझा कुछ कुछ?
yeah.
Can I answer this question?
yeah.
Yeah.
यस
या जैकपॉट.
Bro, when there is a leakage, okay, any holes, any cracks in the refrigeration system,
Okay.
there is low pressure inside the refrigeration system. The air is drawn into the system
Okay.
because of the atmospheric pressure is higher than the refrigeration system.
So yeah, Hifazat was right. We were not giving him credibility. Okay.
यार
So
मैंने
the
थोड़ा थोड़ा
answer
उसको
for
देखा है
this,
इसलिए मैं
no,
बोल
no,
रहा हूँ.
answer for this
क्योंकि
question
ऐसे
is
अपन
just
डालने की जरूरत नहीं रहती है उसमें. जब रिपेयर करते थे ना तो वो टाइम पे डालते थे.
so
Uh,
it's just because of the like, issues in the real life, like leakage and right.
yeah. Guys, air is fitted before evaporator, na? Location of dryer. Sorry, dryer is fitted where?
thermostat expansion wall before the thermostat expansion wall after the condenser.
After condensation, before location of dryer
Yeah, yeah, it's right.
in VCR.
I think I am right over here.
Yes.
Before evaporator, I think.
या
No no,
Before thermostatic expansion.
yes,
Before
before thermostat.
evaporator, you have that what we call it,
Mm,
Thermostat expansion wall.
reservoir.
अरे
There is a
we
reservoir.
directly used to pour it in the expansion valve only.
Uh,
that dryer, silica gel.
Arey, Hifazat,
या.
in
हाँ भाई.
Indian refrigerator, we don't have thermostatic expansion valve. We use
No no, I'm talking
Capillary
about
tube,
the
capillary
refrigerator.
tubes.
we use capillary tube in these
Yes.
small devices. We don't have thermostatic expansion valve.
I'm talking about the refrigerator.
Yeah, in refrigerators also.
That dryer is known as filter dryer.
I guess
Paper dryer, paper.
No, no, filter dryer. A filter dryer is used to remove any particles such as dirt, metal, or chips from the entering the refrigerant flow content.
are you referring the trimmer package?
No, no, I am referring internet. The refrigerant flow control device can be thermostatics. Or here is not mentioned any moisture. Yeah, what we are discussing about. Oh no, no, a dryer as its
Okay,
name,
Yeah,
okay.
no,
actually,
as actually it's
if,
a
if
dryer as its name implies used to remove the moisture from the refrigerant. Yeah, sometimes
yeah,
it is also referred to as dehydrator or dryer. It is necessary to
Yeah.
remove moisture from the system, otherwise it may freeze inside the tube casing the flow of refrigerant to be restricted. The moisture will also causes the formation of acid and let me now search from where moisture come in the refrigerator. From
Okay. So my next question is, hello.
yeah,
Like, what are the process of that is? That means in compression, we know that the compression is like isentropic compression, and the condenser, what type of condenser, like isenthalpic? Anyone knows
yeah,
processes?
yeah. I know processes.
All the
Yes.
processes.
Yeah. Hifaza, tell them na. Tell them.
No, no, no. You are going to tell.
Okay. Okay. So starting with the compressor, it is the isentropic compression. That is the adiabatic compression, reversible adiabatic compression. And the compressor goes then condenser. Condenser. Condenser is the heat rejection process at constant temperature. So it's a isobaric compression. Sorry, isobaric process. And then condenser, then we it goes through thermostatic expansion valve. Thermostatic expansion valve process is an isenthalpy process. Enthalpy is constant while expansion, and then it goes to the evaporator where evaporator absorbs heat at constant pressure. That is known as constant isobaric process. Means two isobaric
Okay.
process,
To
one
Okay.
reversible adiabatic
Hello.
process, and one
Hello.
thermostatic expansion valve process. Now, hello.
Okay. And then take the TS diagram and just see the what is the process of that evaporation. It says that the evaporation has the constant temperature. Why it is like that?
Evaporation has constant temperature.
because
Temperature. Yes.
heat
Yes.
absorb is
It's a phase change, phase change.
yeah, latent heat of evaporation.
Latent heat of evaporation.
That means there is a no sensible heat, na? Only latent heat is absorbed, na?
Correct.
Mostly.
Correct.
So
Correct.
we say that the evaporator is the like evaporation is the constant pressure and the constant temperature process. Can we
Yes.
say that?
Yeah, correct. To some extent.
Yeah.
Anyone?
Yeah, correct. Before under the saturation dome.
Okay. Means
Like
compression is
actually,
ice and ice.
the diagrams which we are talking about are theoretical diagrams, and
Yes.
there's difference between theory and practical.
And
So I think if you actually somehow manage to try the practical diagram, there will be variation of temperature in the evaporation region because
if
The
we
evaporator is
see, if we see,
superheat is there also.
yeah, if we see the actual diagram before condenser, there is curve, there is a pressure and temperature also decreasing, but at the same then after that when getting in the saturation dome, the pressure temperature become constant in condenser also. Constant pressure.
Ah,
so my next question is in pH diagram. Okay. So in pH diagram, like 3 to 4 process, huh? 3 to 4 process that is the expansion process in thermostat expansion. No? So why the entropy is decreasing over here?
Where uh,
entropy is
Decreasing.
TS diagram.
where?
Yeah.
Yes.
In pH diagram, enthalpy pressure is decreasing, no?
No, no,
Means entropy.
Uh,
TS diagram.
pH diagram pH. Sorry, pH na
No,
TS sorry TS diagram.
Entropy is not increasing; it's decreasing.
Decreasing,
No, no,
decreasing.
TS diagram
No,
of
as per
See
PH
that
yeah.
graph?
diagram.
That is not a straight line. That is the somewhere around cross line.
No, no,
Yeah,
it's
but can you just share the diagram, please?
no, no. I am just a TS diagram.
I
I am sending in
अरे
the
अभी
group.
जिमी को घुमा रहा हूँ.
Okay.
ग्रुप पे डालता हूँ
No,
देखो एक
No,
बार.
no,
no,
मैं.
no. Wait, I'll just share the diagram and tell me if the diagram is right or not. Okay.
Okay.
ओके 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 ओके.
TS. यार.
Entropy is not decreasing, bro.
Wait.
uh,
See, the diagrams are right.
कंडेंसर की बात कर रहा
नहीं.
No, 3 to 4 process, so thermostatic expansion valve है ना
है.
उसका
It's
बात.
increasing, bro.
Yeah, it's
Entropy.
increasing.
Yeah, on x-axis, values increase to the right hand side.
हाँ यार.
हेलो
Yeah.
हम्म.
हेलो. तो देखो
Yes.
टीएस डायग्राम देखो. हेलो.
हम्म.
सेम
हाँ.
सेम डायग्राम. हाँ. टीएस डायग्राम देखो. 3 to 4. अगर
Yeah.
3 से हम लाइन नीचे खींचेंगे और 4 से लाइन हम नीचे खींचेंगे तो 3 पर एंट्रोपी कम है
हम्म.
और एंट्रोपी कम है और 4 पर एंट्रोपी ज्यादा है.
हम्म.
ऐसा
Yeah.
क्यों? दिस इज नॉट दैट क्रॉस. आई सर्च फॉर द लाइन. दिस इज नॉट दैट स्ट्रेट लाइन. दिस इज द क्रॉस लाइन.
Bro.
In PS
Why the
diagram,
entropy?
because on the s-axis we have
See, three
entropy,
to
and
pro.
in reality that expansion is isenthalpic, not isentropic.
Yeah, correct.
You're on mute, Gyan.
Oh, sorry. I was saying that 3 to 4 process is isenthalpic process. Its compression is isentropic process. Isenthalpy is not
Throttling process is
isentropic.
isentropic for ideal gases only.
Yeah.
What you told, Kamlesh? Repeat.
Uh, what's happening in the expansion device is throttling,
Hmm.
right?
Hmm.
And that process is isentropic for ideal gases only, not for other gases. Refrigerant isn't an ideal gas.
No, no, no. That process will not be any way isentropic for ideal gas. Also, it's just that
Sure.
if it would have ideal gas, it would have not changed the temperature in the throttling region. But temperature is changing while being isenthalpic process is something like a fluid gas, of refrigerant fluid, because it's not an ideal.
Hello,
I'm
but
very
I
sure.
read somewhere that, and I have the proof of that explanation, which is described in my diploma books, that says that the thermostat expansion valve is a process of isenthalpic,
Yeah.
Yes.
not the tropic.
Isenthalpic and isentropic are two different things, Kiran.
Yes, yes, yes.
So
And in
what we
PS
are
diagram,
saying?
we
We
are
are saying
referring
same.
entropy, and in
You are
pH diagram,
confusing it.
we refer enthalpy. Actually, we have discussed this before.
Yeah, you are right. It's isenthalpic process. In isenthalpic process, entropy is not constant. So entropy is
If
not
you have to
constant
check,
in 3 to
it is
4
not
diagram.
isent.
It's
Yeah.
increasing in 3 to
In
4 process.
in pH diagram, where enthalpy is on the x-axis, you could see that 3 to 4 process is a straight line, vertical straight
Yes.
line, parallel to the p-axis.
Okay.
Is it? Is your doubt clear,
Then
Kiran?
wait, throttling is an
Okay.
isentropic process, right?
Yeah, correct.
No. It's not
Isenthalpic.
isentropic. It's isenthalpic. Sorry, it was
Isenthalpic,
my
sorry.
mistake.
But
It was my mistake.
ओके ठीक है. पर कमलेश ठीक है ठीक है ठीक है. सो ठीक है. एंथैल्पी कांस्टेंट है, बट एंट्रोपी चेंज क्यों हो रही है वो बता. चेंज
Only,
क्यों हो
yeah,
रही है.
obviously. There is volume is expanding.
वॉल्यूम तो कांस्टेंट है रेफ्रिजरेंट का.
अरे नहीं देख,
Expand हो गया.
forget about the
Expand.
refrigerant. Okay,
ओके ओके.
just imagine of a throttling device. This is a pipe. This is a tiny orifice. गैस फ्लो हो रही है, यहाँ पे गैस उस orifice से निकल रही है. So obviously there is increase in volume, decrease in pressure.
Mm.
Get it, get it,
Okay,
get it, get it.
that's why entropy is increasing.
Yeah, the degree of freedom is increasing. The
Okay, okay,
randomness.
okay. Means when we pass the refrigerant from the restricted area, that means the orifice plate, that causes the decreases in pressure.
Mm.
Because
Yes,
of that pressure, the volume is also decreases.
Increasing, volume is
increases.
increasing. From
Yeah,
from will,
see,
it's increasing. Increasing.
Bro,
But hello,
like best example of throttling. our body spray nozzle.
Yes.
Yeah, that's like everyday example of throttling. So you are pressing the button, gas is coming out of it, and it's expanding.
अरे
Okay.
थर्मोस्टेटिक एक्सपांशन वाल्व में क्या रहता है? लिक्विड रेफ्रिजरेंट आता है और लिक्विड रेफ्रिजरेंट ही जाता है, मगर इसके साथ साथ वेपर रेफ्रिजरेंट भी होता है ना, तो शायद इसलिए एक्सपांड हो रहा है, एंट्रोपी इज इंक्रीजिंग, एक्सपांड हो रहा है ना,
मैंने तो
देखना
सुना
वॉल्यूम
था
वॉल्यूम बढ़ रहा है।
मैंने तो सुना कि थर्मोस्टेट एक्सपांशन पर वो गेलुसिफ लॉ अप्लाई होता है, लाइक एट कांस्टेंट वॉल्यूम प्रेशर इज लाइक इनवर्सली प्रेशर इज डायरेक्टली प्रोपोर्शनल टेम्परेचर. It says that at constant volume,
But volume
when pressure
increases,
is
bro.
dropped, there is a drop in the temperature also.
तो गेरोसा क्लॉक गैसेस के लिए भाई, ये गैस थोड़ी है।
और फिर अरे
It's not
अरे
an ideal
गैस नहीं तो
gas.
क्या है? थर्मोस्टेट एक्सपांशन के बाद गैस नहीं है क्या? लिक्विड प्लस वेपर मिक्सचर, तो वेपर तो गैस ही
Ideally,
हुआ ना.
मगर
ideally नहीं है.
It's an
Kiran,
ideal नहीं है.
ideally after expansion valve there must be only liquid, but some of the liquid is getting converted into the gaseous form. That's why we have the mixture. Because most of the refrigerant is in liquid state.
Okay, okay, okay.
Actually, I was also
I
talking
get it.
about which law is governed in the throttling process.
Thermodynamic.
I know the all the laws, like in condenser there is a like four year law of heat exchanger. In the thermostat expansion wall there is a Gay-Lussac's law, and the evaporator, that is the Dalton's law of evaporation.
Yeah.
According to me, yeah.
But no
Yeah,
one
but
mentions
so
while
honest.
explaining that. Just going
So
into.
I don't think so. We should mention about that small laws.
I'm not gonna mention. Even if he's
वो
asking, I just say I don't know. Even if I know, I say
हाँ
I'm not
भाई,
gonna.
और फालतू में मतलब लंबी हो जाएगी चीजें।
And
Kamlesh, and you told the ideal gas can be applied for the refrigerant. Then isenthalpic process is a constant temperature. It will act as a constant temperature, right, for ideal gas.
yeah, I told that.
Then temperature has to be constant. Then temperature
Is not
is
constant.
It's
decreasing.
decreasing.
Decreasing
It's
because
not constant.
it's a real fluid, na. That's why it's decreasing.
Yeah.
Yeah.
Then it will not act as an ideal gas, right? Then it's wrong there.
Say it opposite because it is not an ideal gas. That's why temperature is decreasing. Got
Yeah.
it?
Okay. Yes. Yes.
Guys.
Okay, another thing we should remember that all this process is happening between the latent heat region. If you see properly in the diagram,
Yeah,
everything is happening.
mixed region, na.
Yeah,
Yeah.
yeah. It's in the mixed region
Huh.
where the fluid is getting converted into the gas.
Uh,
So basically, as per my like comprehension, it's process is entirely happening in the wet region where the heat is being exchanged in the form of latent heat.
mm.
Yeah, I just stopped up.
No, yaar. See. After after condenser, we get high pressure saturated liquid, na. High pressure saturated liquid goes in thermostatic expansion valve, become low pressure saturated liquid, which we say chilled liquid. Then is it's showing in the graph is showing like that, creating a confusion that it is in under
देखो भाई,
saturation.
इतनी सी वेपर का ऑपरेशन साइकिल है, उस पे कितने कितने क्वेश्चन निकल रहे हैं. एंथैल्पी क्या है,
नहीं नहीं
एंट्रोपी क्या है,
actually
कुछ क्या हो.
okay.
uh, yeah.
Uh,
When I will be setting the next set of paper for merchant navy decoded, na, I will put all of the questions which we discuss.
मतलब मतलब after like
No
जो
one can able to answer that.
Yeah, can we
ऐसा
segregate
जो
that IC engine and RAC
reverse
and
spec-
these questions of 62 is there, no?
मतलब देने वाली की पूरी लेने वाली बात कर रहा है.
आवाज नहीं तो क्या उन्होंने रिवर्स पैकेज देख के छोड़ देना चाहिए.
Can we segregate the question ICNG and RAC? That 64 questions is there. No, if we segregate, we will get. We can discuss one topic daily. Means like if we
Yeah,
segregate all the
we are
questions.
having very less time at the same time, bro.
Yeah, and if you have time and I have like find the time, just go
If you
ahead.
then from tomorrow I am going to discuss the material which has been sent by Kamlesh bro. The all of the questions we are going to discuss one by one. First we'll be
Okay.
discussing with the with because Obray sir is having your interview na Kiran and Hifazat. So
Yeah.
we will be discussing from tomorrow Obray sir questions only till we will
जितने क्वेश्चन है भेज दो भाई, जितने भी है वैसे भी
already.
मेरा तो कुछ हुआ नहीं है यार.
Hifazat,
हाँ हाँ भाई.
put mic
Put.
away from yourself.
Okay, 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 okay.
Okay.
Is it
Arey,
Uh,
is it okay now?
okay. Clear,
just
clear.
drop the mic from your hand.
अरे भाई, क्या
See,
है ना, अभी मैं थोड़ा पर्सनल थिंग है, इसकी वजह से मैं अभी बोल भी नहीं पा रहा हूँ. तो आदत
नहीं
हो गई
नहीं,
है एक थोड़ी सी.
हाँ, वो छोड़ दे, बस नीचे ही छोड़ दे, हाथ में मत
अरे आवाज आवाज आ रही है मेरी?
yeah, now it's coming
पकड़.
well.
Yeah, this is fine. This is fine.
And Hifazat, bro. Yeah, see, we are going to discuss from tomorrow, and every day we're discussing O'Brien sir every question in very deep, and we'll create a common layman language answer for
भाई
every question.
सुनो ना, ज्ञान
हाँ,
भाई, ज्ञान भाई,
Uh,
कल जितने क्वेश्चन हो सकते हैं ना, निकाल लो. कल
yeah,
तो परसों 3 दिन में.
see,
like
already
Hifazat,
sent by
mostly
Kamlesh,
questions are
bro.
posted on the group.
हाँ,
Already sent
वो तो
by.
वो थोड़ा सा है, वो तो थोड़ा सा है वो तो.
That's
एक्चुअली वो
20.
जो क्वेश्चंस मैंने भेजे है ना, वो जय और मैंने लास्ट टाइम पे बनाए थे.
अच्छा.
जय ने थोड़े भेजे थे, मैंने थोड़े ऐड किए थे, सो
And I think it's a valid question that is being asked by different teachers. I
या
find it genuine. And and see 25 to 30 question are big number. We are taking it such easy. See four question are taking such times of hours. Is it or not? See here he is also asking. I am seeing the O'Brien sir question sets.
सी
It's a
द
26 question.
प्रॉब्लम
We
हियर
will be
इज
discussing that.
क्वेश्चंस.
Okay, from
या
tomorrow.